In this part, we're going to cover working with rational exponents involving with law of exponents. Now, if you need to review with your law of exponents, then I recommend to go back to section 12.1. Make sure you're familiar with it, but I will briefly talk about what to do and give the examples that we have here. So again, we're going to be focused on laws of exponents involving when we're multiplying with same bases or dividing with same bases. And another one would be raising by another power. So let's take a look at the first example. We have m to the power of 2 over 3 times m to the power of 4 over 5. So when it's the same base multiplying, in this case the m's, we're going to add the exponents. So let's rewrite it as m to the power of 2 over 3 plus 4 over 5. So when you're adding exponents, especially when it's a fraction, the only thing that we need to have to make sure that it works is common denominator. So I'm going to write the fraction out here so it's bigger and visible to see. So we have 2/3 plus 4/5, and we need to make sure that they have the same denominator. So the common denominator between 3 and 5 is 15. So that means that the first fraction, I'm going to multiply by 5 to the numerator and denominator. For the second fraction, I'm going to multiply the numerator and denominator by 3. So for the first fraction, I'm going to have 10 over 15 plus, for the second fraction, I'm going to have 12 over 15. So I'm going to actually have m to the power of 10 over 15 plus 12 over 15. So since they have the same denominator, that means that we can add them together, meaning I'm going to have m to the power of 10 plus 12, which will be 22 over 15. Now, when we have a rational exponent, make sure to check if you can simplify the fraction. There's nothing in common between 22 and 15, so that means you're going to leave it like that. And this will be my final answer. So m to the power of 22 over 15. In this example, what's different than the previous one is now we have coefficients in front of the variable. So we have the 2 in front of this a, and we have the 7 on the other a. So let's take a look at the example. We have 2a to the power of 1/5 times 7a to the power of 5 over 6. Now, since we do not have parentheses on the 2a nor on the 7a, that means that the exponent 1 over 5 only applies to the a, and then the other one, 5 over 6, only applies to the second a. So that means that you can multiply the 2 and the 7 together. So we're going to have 14a to the power of, and since we're multiplying with the same base, the a's, that means that we're going to add the exponent. So it's going to be 1/5 plus 5 over 6. And then I'm going to bring the fraction over here to make it bigger and visible to see. So 1/5 plus 5 over 6. Now, when you're adding fraction, same thing, common denominator. So the common denominator between 5 and 6 is 30. So I'm going to multiply the first fraction by 6 to the numerator and denominator. And I'm going to multiply the second fraction by 5 to the numerator and denominator. So on the first fraction, I'm going to have 6 over 30 plus 25 over 30. So let me bring these two fractions back to over here. So it's going to be 14 a to the power of 6 over 30 plus 25 over 30. So when you add these exponents, we're going to have 14 to the power of 6 plus 25. That's going to be 31 in the numerator, and my denominator is 30. So my final answer is 14a to the power of 31 over 30. So let me box that up. And again, always check if you can simplify the fraction. If you can, do so. So again, my final answer is 14a to the power of 31 over 30.